All right, so we got part 2 here from 0 and negative exponents. So just a reminder of the rules. We had anything to the power of 0 is equal to 1. Or I like to say anything to the power of none is equal to 1. Because it rhymes and it's nice, it makes it easy to remember. Power of none equal 1. Then we have with our negative exponents, we said anything to the power of a negative exponent. What you could do is take the reciprocal of your base and your exponent sign will change. Or another way to say that, because it rhymes, we have cross the line, change the sign. Those should be helpful reminders to help you remember how the rules work. But let's see if we can put them in effect. Let's try to do a couple examples and see how they work. I'm going to erase this just so we have more room. So, example 1. I have y to the 5th over y to the negative 3rd. Pretty easy one to start us off. We have 2 different ways I'm going to show you how to do this. First, I'm going to say we have a negative exponent. Let's use one of our rules and make it positive. So I have a negative exponent down here. If I cross the line with it, it'll change the sign. So I bring it up over the fraction bar. And I'm going to rewrite this. This will become y to the 5th times y to the positive 3rd now. And now I'm just using my power of products rule, or my product of powers rule. So I'm multiplying with the same base and I can add my exponents. That's just simply going to be y to the 8th. Now a second way I can think about this problem is using the quotient of powers rule. So let me rewrite it, y to the 5th or y to the negative 3rd. When I divide with the same base, I'm allowed to subtract my exponents. So this can be rewritten as y to the 5 minus negative 3 powers. And whenever I subtract a negative, I'm really adding. So this is y to the 8th. Look at this, we get the same answer in both problems using 2 different methods. So whether you want to turn all the exponents into positive exponents and then simplify, that's fine. Or if you want to use the exponent rules and then possibly deal with negatives later, that's fine too. That's example 1. Example 2. X to the 3rd times y to the 5th times z to the 4th all over x to the 5th times y to the 2nd times z to the 4th. All right, so obviously a little bit longer. We got a lot of variables in here. Here's how I like to think about these problems, and they're a little weird. I like to think about this splitting it up into 3 different fractions. I got my fraction with my x's as the base, my fraction with my y's as the base, my fraction with my z's as the base. And I like to use my quotient of powers rule. So I have x to the 3rd over x to the 5th. That's going to be x to the 3 minus 5 power. And let me use different colors for these. So with the y's, I can use the quotient of powers rule. I have y to the 5 minus 2nd power. And where's my other marker at? Oh, I'll go back to black. So I have z to the 4 minus 4 power here. These are all multiplication, by the way, just if that wasn't clear. So we can simplify here. 3 minus 5 is going to give me x to the negative 2nd. Y to the 5 minus 2 is going to give me y to the 3rd. And z to the 4 minus 4 power is going to give me z to the 0th power. Well, now we have to simplify a little bit more because I have a negative exponent, I have a 0 exponent here. Let's solve those. Let's figure that out. So we said before, when I have a negative exponent, I can take the reciprocal of the base, or I can cross the line and change the sign of my exponent. So this is going to become 1 over x to the positive 2nd power. Y to the 3rd, nothing wrong with that. We're leaving it y to the 3rd. Z to the 0th power, we learned anything to the 0th power, anything to the power of none is equal to 1. So really, that's just a big 1. I mean, we could write multiply by 1, but multiplying by 1 doesn't do anything. So really, we don't need to write that at all. Look what we have here in blue and red. I'm going to write it bigger. I have 1 over x squared times y to the third. I can leave it like that, or I can make it look a little bit better. I could do the multiplication, I can put this, it's y to the third, just right over top of the x squared. There we go, call it a day, we got that simplified. Look at what we started with. That was a big, ugly fraction. Look at what we're ending with. Not that bad. I like it better. All right, if you can do that problem, you can probably do most of these. So I'm gonna stop there. I think 2 examples was enough. Hopefully that helped you out.